Yeah, good evening, children. Good evening, Lakshana.
Good evening, ma'am.
Yeah, I've shared my screen. Is it visible?
Yes, ma'am.
Good. All right, look at this question. Factorize a squared minus 2a the whole squared minus 23 into a squared minus 2a plus 120. So here we find this expression common, right? In this expression, we find this expression common. This itself is an expression. In this expression, we find this expression common. We find this in the first term and the second term. A squared minus 2a, a squared minus 2a. So to make the expression look simpler, you know, we replace a squared minus 2a with y. All right? Fast, come in. Settle down, fast down. Okay. I'm repeating. Listen. So in this expression, I'm repeating for you. Sanjay, I'm repeating for you. Look at the board. You can bring your book out later. Listen. So in this expression, we have this expression a square minus 2a common. So to make the expression look simpler, we replace a square minus 2a with any other variable, not a, because a is already used in the expression. Something else other than a. So maybe x, y, z. Okay, so here I say let a square minus 2a be equal to y. So now rewrite this expression by replacing this one with y. So how will this look like? It look like y squared. This is y, no? So y squared minus 23y plus 120. Yes or no? This is y. So y squared. This is y. So minus 23y plus 120. Now see, it's nothing but a quadratic expression, which can be factorized by splitting the middle term. So what is the sum? What's the sum? Sanjay, what's the sum? No. Here in this quadratic polynomial, what is the sum and what is the product? What is the sum? What is the product? Yeah. So the sum is minus 23, right? And the product is plus 120. The sum is minus 23 and the product is 120. So now we'll have to express 120 as a product of its prime factors. So like this, you do this method. So, or you can just write it like this. See, what is 120? 12 into 10, right? And any tables you can use, any tables. So I write 120 as 12 into 10 and further 12 as 4 threes. You can do that in your mind. 4 threes are 12 and 4 is further 2 into 2. So 12 is 2 into 2 into 3. And what about 10? 2 into 5. So you don't have to actually do this method. You can just write this number using any tables and then further decompose the numbers. So we started with 120 is what? 12 into 10 or 10 into 12 or any other tables for that matter. And then further, if the numbers can be decomposed into their prime factors, do that. That's all. So 12 into 10 and 12 is what? 4 threes are. But what is 4? 2 into 2. So 2 into 2 into 3 and 10 is 2 into 5. So now you'll have to use all these numbers and make two numbers which satisfies the sum and the product. All right. So 3 5s are 15, 2 2s are 4, 4s are 8. 8 and 15. Because 8 and 15 can see when you 8 and 15 when you add you get 23. You don't get minus 23, but you get 23. You get that number, the absolute value 23. 8 and 15 gives you 23. Now fix the signs. Now the sum is negative, and if the sum is negative, then both has to be negative, right? Only then you'll get 23. Because if they take opposite signs, then you will subtract. You will not get 23. when you give opposite signs, plus 8 and minus 15 or minus 8 and plus 15, you will have to subtract the two numbers. Then you will not get the sum 23. So they should take the same sign, plus plus or minus minus. So here it is minus 8 and minus 15. Minus 8 and minus 15. So when you multiply minus into minus plus 8 15s are 120. So plus 120. And on adding, you get minus 8 minus 15 minus 23. So split the middle term. Minus 15y minus 8y or minus 8y minus 15y, and then you know these steps till here. So after that, after splitting the middle term, replace. What is y? A squared minus 2a. Put it back. Y is a squared minus 2a. Y is a squared minus 2a. Put it back. Now again, this is, see, after splitting the middle term, we get y minus 15 into y minus 8. Actually, we are done. But y was not the variable in the question. We had used the variable y, right? So you have to put it back. What is y? A squared minus 2a. So put it back. What is y? A squared minus 2a minus 15. And y? A squared minus 2a minus 8. Now again, in the two brackets, you have quadratic expressions or quadratic polynomials, which you should try to factorize them further by splitting the middle term. You try it. So you write out the sum and the product. If you're able to find the two numbers that satisfy the sum and the product, then you should split the middle term and factorize it further. Sometimes, you might not get two numbers which satisfies the given sum and product. That means the quadratic expression is not further factorizable. Okay. So how to factorize such, expressions you will learn in the next class, standard 10. For now, you have only this method. You will only try to factorize a quadratic polynomial by splitting the middle term. When you see a quadratic polynomial, you will try to factorize it by splitting the middle term. But for that, you should be able to get the two numbers that satisfies the sum and the product. If you're not able to find the two numbers that satisfy the sum and the product, that means the quadratic polynomial is not factorizable. You don't have rational factors. Actually, it's like that. So you can just leave it. Okay, so you try to find the sum, you write out the sum in the product and try to factorize it. So here we find the two numbers that satisfies the sum in the product. So we further split the middle term and, these are the usual steps. And here, these are the four factors of the given expression. Now, if we have trouble with factorizing a quadratic polynomial, then you might think that I haven't explained it clearly. It's like that. So then I'll send a video. Yeah, children start working. Start working, all of you. 9th standard students start working. Yeah, so I was telling you, if splitting the middle term, if you're not sure about splitting the middle term, I'll share a video today of 8th standard where I've explained how to factorize a quadratic polynomial by splitting the middle term. Please watch that video so that you recall how to factorize by splitting the middle term. Okay, yeah, take this down. Write down this. Done writing? Completed, right? All right. I've shared the image on WhatsApp. Complete it later. You too. Okay. I've shared the image on WhatsApp. You can complete it later. Okay. Look at this one. Factorize a cubed plus a minus 1 the whole cube plus 1 minus 2a the whole cubed. So in this expression, we have three perfect cubes. In this expression, we have three perfect cubes. So there's only one identity which involves three perfect cubes. And what is that? That's the conditional identity. A cubed plus b, don't write a cube plus b cube plus c cube is equal, or we'll write it in terms of x, y, z because we have a in the expression already. So we'll use x, y, z. So x cubed plus y cubed plus z cubed is equal to 3x, y, z. Okay, but what's the condition? If x plus y plus z is equal to 0. If x plus y plus z is 0, then x cube plus y cube plus z cube is equal to 3xyz. So we'll have to check if x plus y plus z is 0. So what is x? What is x? A. What's y? A minus 1. And what's z? 1 minus 2a. 1 minus 2a. So now what is x plus y plus z? A plus a minus 1 plus 1 minus 2a. So what happens? A, 2a minus 2a minus 1 plus 1. Yes, it is 0. Since x plus y plus z is 0, x cube plus y cube plus z cube is equal to 3xyz. So the answer is 3 into x. What is x? A into y into z. That's the answer. The question is of the form. X cubed plus y cubed plus z cubed. And the answer, if the question is of this form, the answer is 3xyz. That's the identity, right? X cube plus y cube plus z cube is equal to, the question is like this. So the answer is 3xyz. But you'll have to check something. And what's that? If x plus y plus z is 0. Yes, x plus y plus z is 0. So then the answer is 3xyz. So 3 into x is a, y is a minus 1, z is 1 minus 2. Right on? Quickly. We need to, actually pace up fast. Once you understand, you just have to write down from the board. You finished writing, Sanjay? Okay, next one. This is similar. Yeah. So how many cubes you see here? 3 cubes. You can see 3 perfect cubes in this expression. So which is the identity you would use to factorize this expression? is equal to 3xyz if x plus y plus z is equal to 0. Correct? So we need to check. X plus y plus z. So before that, we'll assume. So x is equal to a squared minus b squared. Y is equal to b squared minus c squared. Z is equal to c squared minus a squared. See, this is x cubed. This is x and cubed. So this is x. This is y cubed. So this is y. This one is y. This is z. This is z cubed. So this is z. What's in the bracket? The whatever is in the bracket are x, y, and z. See here. This one is x cubed. This is y cubed. This is z cubed. So let x be equal to this one, y be equal to this, and z be equal to this without the cubes. Now work x plus y plus z. You have to work that. X plus y plus z is equal to. So add and see everything gets cancelled. It's 0. So since you have checked this condition, if the identities, if x plus y plus z is 0, then x cube plus y cube plus z cube is equal to 3xyz. Yes, we checked it. It is 0. So the value of this expression is 3xyz. 3 into x into y into z. X into y into z. But these are further factorizable because a squared minus b squared is a plus b into a minus b. B squared minus b, c squared is b plus c into b minus c. C squared minus a squared is c plus a into c minus a. Right? Yeah. Finish it. Finished. Understood. Any questions? Any questions? Yes. In x plus y plus z, you're asking why there is no power 3, is it?
Yes.
I didn't say that, no? How do you look at this one? What do you call this? X. This is x and cubed. So this is your x. This is y. This is y cubed. So this is y. This is y. This is z. Z. This one is z. Z cubed. So what is z? This is z. The question is of the form x cubed plus y cubed plus z cubed. But we have to write x, y, z. So without the cube, you should write. Understood, Sanjay? Understood? So what is a squared minus b squared? Sit down, sit down. A squared minus b squared is equal to? Very good. What is a minus b the whole squared? Same answer. A minus b the whole square. No, that is a squared minus b squared. What is a minus b the whole square? What is it here? A squared minus 2ab plus b squared. Okay, next one. In writing? Okay. So this you can help yourself. See here. Work this in step 1, work this one in step 2, and then you can answer this question in step 3. See here. So take up the numerator. Take up the numerator in step 1. Step 1, factorizing the numerator. This is the numerator. Okay. So step 1, factorizing the numerator. This is the numerator. And this we just factorize it. No, see here. It's the same thing. The same thing what we just did. So this is x cubed plus y cubed plus z cubed. So find x plus y plus z. It will be 0. So if x plus y plus z is 0, then this one is 3xyz. So like this, you factorize the numerator. What we just did. Then take up the denominator, factorizing the denominator. Denominator is again x cubed plus, okay, so I've not used x, y, z again. I'm calling this p, q, and r because same question, don't use the same variables x, y, z. So I'm calling this p cubed plus q cubed plus r cubed. All right. So what is p? A minus b. Q is b minus c. And r is c minus a, right? So find out p plus q plus r. P plus q plus r is 0. So if p plus q plus r is 0, then p cubed plus q cubed plus r cubed is equal to 3pqr. Same identity. We're just using pqr. Okay, because here we say x is a squared minus b squared. Again, in the same answer, x is a minus b. You will get marks, but we're just trying to differentiate. That's all. Okay. Yeah, so like this, factorize the numerator and denominator separately. And in step 3, what is step 3? Step 1 answer divided by step 2 answer. What is step 3? Step 1 answer divided by step 2 answer. This is step 1 answer divided by, this is step 2 answer. And you can see that certain expressions get cancelled. And the final answer is a plus b into b plus c into c plus a. Yeah. Now this, please go through, understand, and then write down. Or as you're writing, please understand. Don't blindly copy. Take down the question. Work it as you see on the board or online, children, as you see on the screen. So, Anita, what's the identity we using here in this answer? If correct. Okay. Yes. Finished. Understood. So what's the identity we're using here? Okay, so this one. This one. Read that for me. You finished polynomials in school? Okay, so you're learning algebraic identities. They're part of the same thing, but you don't find this question in NCERT, but it's a part of algebraic identities. Yeah, so what's the identity we are working on in this one? You didn't put the if in the right place. What is the condition and what's the identity? 0, that's the condition. If x plus y plus z is 0, then okay. So Rahul, what is completed? Is this over? Have you finished working this in your book? Go to that N, Shreya. Just, yeah. Lakshana, any questions?
No, ma'am.
Okay. Okay. Next one. So now this you're going to do by yourself. Very similar to the earlier one. Try this by yourself. You can compare this question with the earlier one. Very similar. You'll have to factorize the numerator, factorize the denominator. So step 1, factorizing the numerator. Step 2, factorize the denominator. And then step 3 is step 1 by step 2. Yeah, this one I have the answer in two different slides. Okay, so similar to the earlier one, right? So the identity we use is the conditional identity. Since we have X, Y, Z in the question, I have written the identity using ABC for the numerator and LMN for the denominator. I've written the same identity using ABC for the numerator and PQR or LMN for the denominator. No. No. Yeah. Yes. It's the same. If you can use PQR here. That's fine. Okay. So what is the numerator like? A cube plus B cube plus C cube. So check A plus B plus C. It is 0. So A cubed plus B cubed plus C cubed is equal to 3xy, 3ABC, 3ABC. But this is further factorizable, right? This is further factorizable. What is 4x squared? 2x the whole square. And 9y squared is 3y the whole square. Correct? Yes. So again, 9y squared is 3y the whole square. 16z squared is 4z the whole square. This is 4z the whole square, and this is 2x the whole square. So you can express these three in the form a squared minus b squared. So which is a plus b into a minus b. This one is a plus b into a minus b. This one is a plus b into a minus b. That's about the numerator. Factorizing the denominator. This is the denominator. So let this be L, this one be M, and this one be N. So find L plus M plus N. It's 0. So L cubed plus M cubed plus N cubed is equal to 3LMN. So this is the question, bro. So write this one. This one is equal to 3 into L into M into N. Now in step 3, numerator by denominator is equal to numerator answer here, this one, divided by denominator answer here. So certain expressions get cancelled. These 3 and 3 gets cancelled. These expressions get cancelled. And we are left with 1, 2, 3, these 3 expressions. So 2x plus 3y into 3y plus 4z into 4z plus 2x. All right? Yeah. Yeah. You've used what in the numerator? No, don't bother about these letters. You can use any letter. See, because in the question we have x, y, and z. I'm not using x, y, z in the identity. That's all it is. I'm using different letters. I think I left you with this slide for quite some time, right? So you check this one. Yeah, now check this. Check your answer with the answer here. Yes. Yeah, children. Got it? Let's recall the identities. Complete this one. What is a cubed minus b cubed? Lakshana, what's a cubed minus b cubed?
A minus b into a square plus ab plus b square.
Very good. Rahul, what is a minus b the whole cube? 3ab. A minus b. Very good. Yeah, who can tell me, who can complete this a cubed plus b cubed? No, not a cubed. Very good. What's a plus b the whole cube? A cube plus b cube plus b into a plus b. Very good. Now what is a cubed plus b cubed plus c cubed minus 3abc? Complete this identity. A cube plus b cube plus c cube minus 3abc is equal to? Very good. So this is the identity we are going to use here. And one more identity involving cubes is a cube plus b cubed plus c cubed is equal to 3abc if a plus b plus c is 0. If a plus b plus c is equal to 0. These are the identities involving cubes. These are the identities involving cubes. Quickly make a note of all this. You already have it in the introduction, but just write out again. These are all the identities that involve cubes. Yeah. Are these all algebraic identities? Yeah. They don't change. Yes, yes. You can change the letters. Now, we have written these identities using A, B, and C, right? You can use any other letter. You can use X, Y, Z, P, Q, R, L, M, N. Yes, it will be in the same format. Yes. Now look at the expression in the question. How many terms? 4 terms. How many perfect cubes? 3 perfect cubes. So which identity? 1, 2, 3, 4, 5, 6. Which one? Which one? Number. Fifth one. See the expression in the question. 4 terms. 4 terms. And these 3 are perfect cubes. These 3 are perfect cubes. So find the identity here. We have 6 identities that involve cubes. So find the identity here that has 4 terms with 3 perfect cubes. So the fifth one, it's the fifth one. See here, the left-hand side of this identity, has 4 terms, 1, 2, 3, 4 terms with 3 perfect cubes. The signs need not match. That will take care. Okay, you can see 3 perfect cubes, A cubed, B cubed, and C cubed, and the fourth term, 3ABC. And compare that with the expression here. See here, cube, and the fourth term. And so this should be 3ABC. All right? Okay. All right. So let's understand the question. Find the value of this expression when S is equal to R by 3 plus 5T. So you'll have to find the value of this expression. So we'll first factorize this. See, whenever you have an expression, default, what you should do, you should factorize it. Find the value. Find the value doesn't mean that you have to do something else. Nothing else can be done with this expression. It has to be factorized. Whatever be the heading, you have to factorize and then answer this question. Find the value. Okay, we'll find the value, but we'll first factorize and then find the value. Okay. Okay. So first factorize. Write the identity. So now we identified the identity that goes with the expression given. So write that identity. Okay, so see here. This is the identity that matches with the expression given here, right? Now, write on this, write the identity first, and then write on the question given, and express these 3 as perfect cubes. So use empty brackets. See here. Use empty brackets. A cubed plus B cubed plus C cubed minus 3 into A into B into C. There are 4 terms, right? There are 4 terms. So 3 perfect cubes, A cubed plus B cubed plus C cubed minus 3ABC. So what should I fill in the first bracket? 1 by, not 27, 1 by 3. 1 by 3 R. So what is 1 by 3 R into 1 by 3 R into 1 by 3 R? R into R squared. R squared into R cubed. 1 by 3 into 1 by 3 into 1 by 3 is 1 by 27. Okay. So 1 by 3 R the whole cubed. 1 by 3 R the whole cubed. Next one. Because 3 into 3 is 9 and 9 into 3 is 27. Yeah, so in the second bracket, S, but it's minus S. Then third bracket, 5T. And here 3ABC, 3 into 1 by 3R into minus S into 5T. Yeah. So now check. Now check. This one is this term. This one is this term. This one is this term. And this one simplify. 3 and 3 cancels. And minus into minus is plus 5RST. Minus into minus plus 5RST. See here, 5RST. So the first step is to present the given expression in the form of the identity. Present the given expression in the form of the identity. So see here, this is the question given. This is A, the whole cubed, plus, take the signs from the identity, plus b the whole cubed plus c the whole cubed minus 3 into, this is a, which is a, this is a, into b into c. That's the first step. You need to show that the given expression is of the form a the whole cubed plus b the whole cubed plus c the whole cubed minus 3 into a, b, c. They are here only. This is a, this is b, this is c. Now simplify this. 3 and 3 gets cancelled. Minus into minus plus 5 RST. Okay, 5 RST. This one goes with this goes with this goes with this, and this one goes with this one. So yes, this expression is perfectly of this form. So then what's the answer? The question looks like the left-hand side of the identity. So what's the answer? The right-hand side is the answer. This is the answer. The question looks like the LHS. So the answer is the RHS. This is the answer. So the answer is 1 by, what is the answer? A plus B plus C. So this is A. This is A plus, this is B plus, this is C. Okay, let's write out what are A, B, and C. What is A? 1 by 3 R. What's B? Minus S. What is C? 5T. So see, this is the question. This is the question. So this is the answer. So write the answer. Instead of A, B, C, you'll have to write these terms. Okay, so A plus B plus C. So this is A plus, this is B plus, this is C. A plus B plus C into A squared plus B squared plus C squared. So A squared plus B squared plus C squared. See, A, B, C are here. Then minus AB minus A into B. What is A? Minus A into B. What's A? 1 by 3 R into B minus S minus BC. Take all the signs from the identity. Minus BC minus, what is B? Minus S. And C, 5T. Minus CA. So minus C. What is C? 5T. A, 1 by 3R. 5T, 1 by 3R. A plus B plus C into A squared plus B squared plus C squared minus AB minus BC minus CA, where A is this one, B is this, and C is this. And this first line is about showing that these terms are of the form A the whole cubed plus B the whole cubed plus C the whole cubed minus 3ABC. Now simplify. So open the bracket. So minus into plus minus, open up the brackets and simplify all this. And you have this. Simplify meaning what? Minus into minus plus, multiply and write the results. Now take the the other information given. What is it? S is equal to R by 3 plus 5T. S is equal to R by 3 plus 5T. So see here, don't you see R by 3 here? R by 3. R by 3 here. And plus 5T here. Can we see that? Can we see R by 3 here? 1 by 3 R is what? R by 3. 1 by 3 R is R by 3. R by 3 plus 5T. Can we see that here? Yes, we can. Yeah. What is that given to be? What is that given to be? What is R by 3 plus 5T? It is S. So instead of R by 3 plus 5T, we'll use S. So you'll have S minus S, right? Yeah. Don't get that? We are given that R by 3 plus 5T is equal to S, right? So here we have R by 3. This is R by 3. This is plus 5T. So take away these two, R by 3 plus 5T. Take away this and write S, because that's what is given. So we have S minus S. We are continuing. We are continuing. So we have S minus S in the first bracket. In the first bracket, instead of this, we write S and then this minus S. And the second bracket as it is. Second bracket as it is. Now what is S minus S? 0. So 0 into the second bracket, which is 0. So the value of this expression is 0. All right? Right on? Sorry? Done, children? Yeah. All right. Yes. Hmm.
So, the final answer, already we have a substitute the value of the experiment.
Yeah, you can do that also. Where you can also do that where you have S. So you can also do that where you have S. So now 1 by 3 R minus what is S? R by 3. R by 3 plus 5t. Yeah, you can substitute that also. Then it will be plus 5t. Plus 5t, correct? 1 by 3 R minus what is S? R by 3 plus 5t. See, we put that in a bracket because it's a minus sign here. When you're writing something after the minus sign, always put that in a bracket. If it's only one term, it's okay. If it's more than one term, put it in a bracket. Then this plus 5t, this is what you are asking, right? Yeah, so in the next step, it will be what? The second bracket as it is. Then it will be 1 by 3r minus r by 3 minus 5t plus 5t. When you open the bracket, minus r by 3 minus 5t, correct? So cancel 0. Yeah, try this one. So Lakshana, what's the identity to be used here?
Ma'am, it is a plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc and plus 2ca.
Very good. Very good. Yeah, correct. Okay. So you'll have to write the identity relevant to the information given here. You'll have to select an identity relevant to the information given here. So here we have a squared plus b squared plus c squared is equal to 80 and ab plus bc plus ca is equal to 9 by 2. Find a plus b plus c the whole cube. So you'll have to find out in which identity you find such expressions. A plus b plus c, a squared plus b squared plus c squared, a b b c c a, which is that identity which has these expressions. So the identity which has these expressions is a plus b plus c, the whole squared is equal to, see here it is whole cubed. Don't worry about that. We have all these expressions in this identity. A plus b plus c, the whole squared is equal to a plus a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Or you can also write a plus b plus c the whole squared is equal to a squared plus b squared plus c squared plus 2 into ab plus bc plus ca. You can take out 2 common. Now see, look at the expressions involved in this identity. Look at the expressions involved in this identity, a plus b plus c. A squared plus b squared plus c squared. Okay, ab plus bc plus ca. So what's the value of a squared plus b squared plus c squared? Shreya? No, you should concentrate. What is the value of a squared plus b squared plus c squared? What's the value of a squared plus b squared plus c squared? 280. This is 280 plus 2 into What's the value of AB plus BC plus AC? 9/2. So 2 and 2 gets cancelled. Yeah, so what is 280 plus 9? 289. And what is 289? It is A plus B plus C the whole square. A plus B plus C the whole square is 289. Then what is A plus B plus C? It's a square root of 289, which is 17. 17 into 17 is 289. So after reading the question, you will have to write the identity that contains these expressions. So this is the identity that contains the expressions given the question. So write that. So how many expressions actually? How many? In this identity, we have A plus B plus C. 1. A squared plus B squared plus C squared. 2. AB plus BC plus CA. 3. There are 3 different expressions in this identity. Of these 3 expressions, we know the values of 2 of them. We know the values of 2 of them. A squared plus B squared plus C squared is 280 and AB, BC, CA 9/2. So in an equation, we have 3 expressions and we know the values of 2 of them. So you can find the third one. So the value of the third expression A plus B plus C is 17. Now what is A plus B plus C the whole cube? 17 cube. 17 cube. Write down. Completed? Okay. Okay. So Shreya, how do you know that you have to write this identity? Rahul, how do you know that you have to write this identity? No, Rahul, no. Why should you write this identity? No, but how do you know there are so many identities? No, how do you know that you have to write this one out of all those identities? Correct. So because in the question we find these expressions A squared plus B squared plus C squared, AB plus BC plus AC. We are given the values of these expressions. And we also have this expression A plus B plus C. We'll have to find A plus B plus C the whole cube. So look at the expressions in the question. A plus B plus C, A squared, B squared, C squared, AB, BC, CA. So you'll have to write that identity which has these expressions. Only then you can use the values given, right? Yeah, so we write this identity. On taking 2 common, the identity looks like this. Now see the expressions here, A plus B plus C, A squared plus B squared plus C squared, AB plus BC plus CA. What's the value of A squared plus B squared plus C squared? 280. Then 2 into this one is 9 by 2. So on simplifying, 289, a plus b plus c, the whole square is 289. So a plus b plus c is square root of 289, which is 17. So a plus b plus c is 17. A plus b plus c, the whole cubed will be 17. See, like a is 5. So a cubed will be 5 cubed, which is 125. If a is 5, then a cubed will be 5 cubed, which is 125. Similarly, a plus b plus c is 17. So a plus b plus c, the whole cubed will be 17 cubed, which is 17 into 17 into 17, which is 4913. All right. Oh, sorry, by mistake. Sorry. Yeah. Thank you. Typing mistake. Sorry. 2AB plus 2BC. Please check that. The new girl. 2BC, ma. Thank you, Rahul. Well, typing have gone wrong. Yeah. 2BC. 2BC. Okay. Next one. Now look at the expressions. A plus B plus C, A squared plus B squared plus C squared, A cubed plus B cubed plus C cubed minus 3ABC. So we have to write this identity. A cubed plus B cubed plus C cubed minus 3ABC is equal to A plus B plus C into A squared plus B squared plus C squared minus AB minus BC minus CA. Then you'll have to make a small change. A plus B plus C, take a square bracket, A squared plus B squared plus C squared, take out minus common here. So in the bracket, you will have AB plus BC plus CA. Which one? Because only then you can see, we have the values of A plus B plus C, which you can substitute here. We have the value of A squared plus B squared plus C squared, which you can put here. Now, this one is not one expression. These are three different terms like minus AB, minus BC, minus CA. I have taken out minus common so that I can fit this in. I can find an identity wherein we have this expression AB plus BC plus CA. When you take out minus common, we get in the bracket, we have AB plus BC plus CA, right? Because minus into AB is minus AB, minus into plus minus BC, minus into plus minus CA, right? Okay. Please listen. So write it like this. A cubed plus B cubed plus C cubed minus 3ABC. Take out the minus common and show the different expressions in this identity. So now let's see the different expressions in this identity. We have A cubed plus B cubed plus C cubed. Then actually ABC is also an expression. Okay, then A plus B plus C. Then A squared plus B squared plus C squared. And then AB plus BC plus CA. These are the different expressions in this identity. The different expressions in this identity are AB plus BC plus CA, A squared plus B squared plus C squared, A plus B plus C. Now here for this answer, actually you can take this one as one expression because we have to find A cubed plus B cubed plus C cubed minus 3ABC. So you can take it as one expression. But there are questions where here you can take this whole thing as one expression. But there are questions where you have to take this as one expression and ABC as a different expression. There are questions like that. Okay. Now, how many expressions does this equation have? How many expressions? 4 expressions. Now you have to find. So we have to find the value of this one, right? This one is what we don't know. Correct? We don't know the value of this one. This is what we have to find. So if you have to find this, that means you should know this, you should know this, you should know this. You should know the value of this expression. You should know the value of this expression and this expression. Do you know the value of this expression a plus b plus c? Yes, 9. Do you know the value of this one? Yes, 35. But we do not know the value of this expression ab plus bc plus ca. So you need to find the value of this expression using a different identity. Now you should think of the identity which has this expression AB plus BC plus CA. You must use that expression, find the value of AB plus BC plus CA, and then use it here. See, understand that the value of A cubed plus B cubed plus C cubed minus 3ABC can be found only using this identity. To find this value, we have to use this identity. For that, to find the value of this one, we need three values. We need the value of this, and this. We know the value of this one and this one, but we don't have the value of this one. So we should find the value of this using a different identity which has this expression. And which is that identity? A plus B plus C the whole squared. A plus B plus C the whole square is equal to A squared plus B squared plus C squared plus 2 of AB plus BC plus AC. See here? This identity has this expression. So what is A plus B plus C? 9. 9 squared is equal to, this is 35, plus 2 into AB plus BC plus AC. So find the value of AB plus BC plus AC from this identity and put it here. So now we have all the three values. Simplify them and find the value of A cube plus B cube plus C cube minus 3ABC. Welcome. See you. Thank you. Finished? Okay. So identifying the identity is easy. Just based on the expressions, whose values are given in the question and what you have to find. Looking at the expressions in the question, you can decide which identity to write. So this is the identity. And I told you should take out minus common here. So when you take out minus common, the identity looks like this. Now see the different expressions. This is one expression, 1, expression 2, expression 3, expression 4. All right. Now, when there are 4 expressions, you need to know you have to find the value of this expression. You need to find the value of this expression. That means you should know the values of these 3. You must know the values of these 3. No, but we know the values of only this one and this one. We don't have the value of this. So you need to find the value of this one using a different identity. See, that's what I mentioned here. This is what we have to evaluate. This is what we have to evaluate. That is find. This is what we'll have to evaluate. This value is given. This value is given. This one is not given. This one only we have to find. So you can't write not given for this. You cannot write not given here. This is what we have to find. Then how will it be given? Okay, so this is what we have to find. Then how will it be given? So this is to evaluate. That's what I've written below here, to evaluate. The value of this expression is given. The value of this expression is given. This one, to evaluate this, we should know this one also, but this is not given. So we have to find the value of this expression using a different identity. And this is the identity that has the expression AB plus BC plus AC. So from which identity can you find the value of AB plus BC plus AC? From this identity. Why? Because it has AB, BC, AC in it. So write the identity. See, you can write this one straight away. You can write this one straight away. You don't have to write this and then take out 2 common. You don't have to write this and then take 2 common. You can write this directly. So now substitute the values. A squared plus B squared plus C squared is 35. It's given in the question. Then this plus 2 into AB plus BC plus AC is equal to, this one is given 9 squared. So now it's not 35 plus 2, children. It's not 35 plus 2. You can go wrong here. It's not 35 plus 2 because 2 is in multiplication. It is 2 into AB plus BC plus AC. It is 2 into AB plus BC plus AC. Okay, so this is one expression, 2 into AB plus BC plus AC. So it's plus 35. So this is, this comes to the other side as minus 35. Do not add 3 and, do not add 35 and 2. 2 is not free to be added to 35. It is 2 into AB plus BC plus AC. So bring 35 to the other side, minus 35. So 81 minus 35 is 46. And now this 2 comes for division by 2. The 2 comes for division, 46 by 2, 23. So the value of AB plus BC plus AC is 23. So we found the value of this expression using this identity. Now go back. I've called this one 1. I've called this identity 1. So substitute the values. Now that we have the values of all the expressions. So see, I've written this one here. Then I put the values. What is AB plus BC plus AC? 9. I put it here. Then what is this one? 35. So that's what I put here. And then minus AB plus BC plus AC. So minus 23. So we're substituting the values in 1. And yeah, work on this, simplify this. It's 108. All right. Yes. No. A squared plus B squared is not equal to A plus B the whole squared. A squared plus B squared is not equal to A plus B the whole squared. A squared minus B squared is not equal to A minus B the whole squared. A cubed minus B cubed is not equal to A minus B the whole cube. A cubed plus B cubed is not equal to A plus B the whole cube. A plus B, A squared plus B squared plus C squared is not equal to A plus B plus C the whole square. Not equal. Completed, all of you? Yeah, try this. It's quite similar to the earlier one. Try this one. Completed, Lakshana?
No, ma'am.
Okay. Once you're done, let me know.
Yes.
Got it, Sanjay?
Ma'am,
One second. Yes, Lakshana?
ma'am, I got it as minus 135.
Minus 135. No, I have a different answer. Just check. Yeah, louder. Okay. Got it, Rahul? Okay, what are the this is the identity, right? X cubed plus y cubed plus z cubed minus 3xyz is equal to, what is it, Sanjay? Is equal to x plus y plus z, x squared plus y squared plus z squared minus, okay, so how many expressions? 1, 2, 3, 4 expressions. Which one has to be, which expression has to be evaluated? The first one. This is to evaluate. And what's the value of this one? 9. This is given 9. This is given 9. This one not given. This is not given. And this one, it's given 23. It's given. Correct. Correct. This is same values. Oh. Okay, so this is not given, right? So how will you find the value of this expression? Yeah, x plus y plus z, the whole square is equal to x squared plus y squared plus z squared plus 2 into xy plus yz plus xz. What I normally do, no, we have to find the value of x squared plus y squared plus z squared, right? Whatever we have to find, that part I'll write it on the left hand side. See, I normally write it like this: x squared plus y squared plus z squared plus 2 into xy plus yz plus xz is equal to x plus y plus z the whole square. I'll have that side of the identity on the LHS whose value we have to find. You can write the identity either ways, right? So because we have to evaluate or find the value of x squared plus y squared plus z squared, I'll write that on the LHS. So x squared plus y squared plus z squared plus 2xyz, sorry, plus 2 into xy plus yz plus xz is equal to x plus y plus z the whole square. Now substitute the values. This is not known. We have to find this. Plus 2 into, what's it? 23 is equal to 9 squared. So you can work this and find the value of this expression. Then substitute that in the first one and find the value of this expression. Lakshman, let me know where you have made a mistake. You got it right, no? Rahul, you got it right?
Ma'am, actually for the value of xy plus yz plus zx, instead of 23, I wrote it as 32.
Oh, okay, okay. Okay, you can also do it like this. 1 minute. Let me just correct this. I explained it in a different way. Let me just write the same thing here. What is on my presentation is correct. But I explained, yeah. So I just made the corrections to, suit what I explained. Same, yeah. Numbers alone, yeah. Numbers are the same, but yeah, correct. Correct. Finished? All right. Finished? Yeah, try this one. Since it's time, I'll just present the answer. You can just help yourself. Everything is mentioned. What is given, what's not given, I've mentioned everything. So whatever is not given, we should find that first. That not given is x squared plus y squared plus z squared, and that we can find using this identity. Yeah. Completed? So tell me the two identities. Look at me and tell me, Sanjay. Tell me the two identities you have used in this question. Three XYZ. Sit properly. Navid. Minus AB, minus BC, minus CA. You started with XYZ and then you are using ABC. You're still to memorize the identities, is it? Next class when you come, please make sure you have memorized all the identities. Minus? What the answer, Rahul? Or to Anita? You got it? Is 70 the answer? Yeah. Or not it? Okay. Okay. Easy? Lakshana completed?
Yes, ma'am.
Okay. Any questions, Lakshana? Is it clear? Or you have any questions?
No, ma'am, I don't have any questions.
All right. All right, children. So that's it for today's session. Thank you so much. Good night. Lakshana, you may leave the call. Thank you. Good night.
Thank you.